Today's lesson, we're going to talk some more about box and whisker plots, and we're going to be introducing the idea of an outlier, which we've kind of discussed previously, but we're going to make sure we have a formula for how to exactly find it today. Let's get started. All right, so for our example here, the number of words in the last 13 texts sent by a friend are 6, 19, 5, 2, and so on. The question we have is, do you notice anything unusual about the data? Is there anything about the numbers that make them stand out, good or bad? And as we look at them, 19 stands out as a number that might be a little too big. And if it is, we will call it an outlier. Throughout this lesson, we're going to explore what an outlier is and how we identify it, and then how it affects our 5-number summary in addition to some of our other statistics. Let's get going. All right, before we do that, let's go ahead and find our 5-number summary. I have gone ahead and rearranged the numbers so that they are in numerical order. You can see we start with 1 all the way to 19. We're going to go ahead and divide this up to find our median, our lower quartile, our upper quartile, and then our min and our max. Go ahead and try that now and hit pause, and then come back and check your answers with what I have. All right, so I went ahead and found our 5-number summary. The exact middle number is 5, so that's our median, Q2. And then once we have our median, we have the lower portion and the upper portion. For our lower portion, the median is going to be 2, which is then Q1, our lower quartile. For the upper portion, the median is going to be 6, which is then Q3, our upper quartile. And then finally, we have our max of 19 and our min of 1. Now we're going to take those numbers and set up a box and whisker plot. All right, let's go ahead and set up our number line. So to begin with, we're going to start with 0, 10, and 20. Each one of our numbers from our 5-number summary is going to get represented by a dot on our box and whisker plot, on our number line. So I'll put a dot at 1. We'll put a dot at 2, a dot for 5, a dot for 6, and these are approximations, and then a dot for 19. And their instructions say just create the box. So we're going to just connect our box, which is done with our quartiles. And the reason why we're just creating our box is look how far away 19 is from the rest of your data compared to how far 1 is from the data. This is a very long gap. We would definitely say it's right skewed as a result. But we want to make sure that this number isn't in fact too large. So we would go through the process of finding our outliers. In order to find the outliers, we are first going to need to find the IQR, which is your interquartile range. And to do that, we would do Q3 minus Q1, which ends up being 6 minus 2, which is 4. So we're going to use that number in our calculation where we're trying to identify our outliers. All right, so we've been discussing this outlier. Let's go ahead and define it. An outlier is a number that is too large or possibly too small. So just to kind of summarize, it doesn't fit. And what we're going to be doing is find our boundary lines or our boundary numbers. So we have a maximum and a minimum that we're allowed to go based off the number set. To figure out what that limit is, we have for our upper limit, Q3 plus 1.5 times the IQR, which is your interquartile range. And then to find your lower limit, it's going to be Q1 minus 1.5 times, again, the IQR, our interquartile range. So by doing these calculations, we're going to set limits for our data set, a upper limit and a lower limit. And then any number that we have that is outside of our range or our limits will be considered an outlier. So let's go ahead and use this to determine if 19 is an outlier. Let's go ahead and just review our steps here before we find our outlier. Step 1 is, again, we want to figure out what our IQR is. That's your interquartile range. And just to reiterate, that is going to be Q3 minus Q1. And we said that that was 4 for our actual example. Once you find your IQR, you're going to take that number and multiply it by 1.5. So we would have 4 times 1.5, which in this case is 6. And then we're going to find our limits. So we're going to take that answer, that's 6, and we're going to do two things. We're either going to be subtracting it from our Q1, or we're going to be adding it to our Q3. So, all right, our Q1 was 2, which means you have 2 minus 6, and that's going to be negative 4. And that creates our lower limit. For our upper limit, we have our Q3, which was 6. 6 plus 6 is going to be 12, and that is now our upper limit. Once you have your limits, we're going to figure out, do we have any values that lie outside of the limits? So do we have a number that is smaller than -4 or a number that is bigger than 12? If we do, then we're going to call them an outlier. And then finally, an outlier is going to be represented with a star on your graph or just another dot. So we're going to go ahead and look at our values. Our biggest value was 19, and our limit was 12. Since 12 is less than 19, since again our limit is less than one of our values, this value is too big. We should also check our other number. We have -4, and that is less than 1, which is a minimum, which is okay. This would have to be the opposite. We would have to have a 1 being less than -4 for it to be too small, or on the left side. Knowing that we have an outlier, it can affect different things for our data, not just the box and whisker plot. So what we're going to do right now is we're going to calculate the mean and the median with and without the outlier. So go ahead and pause the video and try and find those on your own. And then once you have them, go ahead and check back in and see what your answers are. The mean for our data with the outlier is going to be 5.86. And then we already calculated the median. The median is going to be 5. Now let's go ahead and take out the outlier and see what that does to our data. The mean without the outlier ends up being 4.75, and the median stays at 5. Let's talk about the means real fast. 19 was a big outlier. So when you take away a big number, it's automatically going to make your mean less, and we definitely saw that happen. We had a mean of 5.86, we took away a big number, and our mean got smaller. If our outlier was on the left side, if it instead was a small number and we took it away, you would see the mean get larger. So we'd have the opposite effect here. For the median, it's kind of hit or miss thing. We saw that the middle was 5. When I took away an outlier, we still had enough 5s in the middle to make our median a 5. But that's something that just kind of you have to double check. We don't really know what's going to happen. But for sure with the outliers, if we take away a big one, it makes our mean smaller. If we take away a small outlier, it's going to make our mean bigger. All right, so here we have another example where we have a data set. We have some numbers that represent the temperature on June 21st over the last 10 years. What I'd like for you to do is go ahead and put these in order and then create your 5-number summary. Then we want to calculate, are there any outliers, something that's too big or too small. So go ahead and hit pause now and then check back in to see how you did. All right, so I went ahead and relabeled our numbers down the bottom here. You can see we have our smallest to our largest in order to be able to find our medians and our quartiles. For the median, we want to find the exact middle, and it turns out that it's going to be between our 90 and 92, which means we're going to average it, and that's how I got 91 as our median, or Q2. We then have two portions. We have the lower portion, and we have the upper portion. The median of the lower portion ends up being in between it's exactly our 89. The median of your upper portion is exactly 94, and then we have the minimum, and we have the maximum. What we're going to do now is use our quartiles. We're going to use Q1 and Q3 to calculate our IQR, which means we're going to get 94 minus 89, which is 5. We're going to take that value, and again, we're going to multiply it by 1.5 and then add it to Q3 and subtract it from Q1. So to find our upper limit, again, it's Q3 plus 1.5 times 5. We're going to calculate what we get for that. And then for our lower limit, we're going to do 89 minus 1.5 times 5 to figure out what our lower limits are. All right, so for our upper limit, we should get 101.5. And for our lower limit, we should get 81.5. Looking at those numbers now, we want to see, do we have something that's too big or too small? So since our upper limit is 101.5, but we can see that we have a number that's bigger than that, then we have to say that 103 is actually going to be an outlier. And our lower limit is 81.5, and again we can see that we have a number that is smaller than that, so once again we have an outlier, 77. Let's go ahead and take a look at how this affects creating our box and whisker plot, knowing that we have in fact outliers. Okay, so I went ahead and set up our number line. Now I'm going to go ahead and put a dot for our original 5-number summary. We had a dot at 77. We had a dot at 89, a dot at 91, another number at 94, and then finally 103. Now the 77 and 103 ended up being outliers. So what we're going to end up doing is we're going to make that a star to show they were in fact outliers. And since those were outliers, we now need to find a new minimum and a new maximum. Turns out that our new minimum is going to be 89 because that is the next smallest number. Our new maximum is going to be 97 because that was the next biggest number. And we have an interesting thing here because 89 is our minimum and it is also our quartile. So we're actually not going to have a whisker on that side. What we're going to have for our box and whisker plot is something that looks kind of like this. And again, I just want to reiterate, we don't have a whisker on the left side because the quartile and the minimum were the same value. And we haven't seen that happen yet, but that does in fact happen sometimes. Alright guys, that concludes it for our notes today. Go ahead and start working on homework number 3, the problems with box and whisker plots and outliers. Good luck, have fun.